Hello, we are beginning our afternoon session for day 3 of the TIEMS 2022 annual conference, coming to you from outside of Atlanta, Georgia, USA, and across the world. We have a slight change in our program. We'd like to welcome as our first speaker in our first session this afternoon, which is involves Chinese perspectives on emergency management. We'd like to welcome Johnston Wong, who is with Social Workers Across Borders. We'll be talking about typhoons, droughts, and low temperature disasters in China using GIS for better EDRM. Johnston, welcome. It's good to see you again.
Yeah, nice to see you again, Tom. It's so nice to see old friends and Harold as well, and Roman. Yeah, it's make me very happy. So I think all of you can see my screen. So today I'm going to share with all participants that how to use this GIS to actually help us to do better EDRM. And then we are formulating or actually designing a disaster map. So I'm speaking on behalf of the team of 4, including Gabriel Owusu. He is from Kenya. And then he also helped us to compile certain parts of the information. So if I can bring the audience back to the Sendai framework, actually, the Sendai framework has made a big contribution in identifying the priorities. Of course, this is related with disaster management policy. So the number 1 priority is understanding disaster risk, which is not an easy task. And it is related with my presentation today. And then number 2 priority is strengthening disaster risk governance. Governance means organization, laws, and also clear policy statements. And number 3, we talk about resilience. And then number 4, we talk about enhancing preparedness and then build back better. So everything starts, I think, with understanding disaster risk. And sometimes it is not as easy as we think. So this research or a small study actually is trying to use GIS, Geographical Information System, to present or further study or analyze the disaster in China. And then it can have several benefits. First of all, it identifies the key problems, and then it also allows us to study trends and then guide mitigation strategies and then measure improvements. So it is, in a way, a kind of information management system trying to bring us through the whole process of disaster management. And then we can use big data to help us to monitor the whole process. All right, so I would like to give you some example how it works for us. Okay. In this study, we selected 9 areas of disasters in China. We have 7 areas belongs to natural disaster: earthquakes, droughts, forest fire, low temperature, typhoons, and then geological incidents, and then floods. And we also included 2 human disasters, which is work-related injuries and traffic accidents. So it is a good balance, I think, because we can cover 2 major areas, 2 types of disasters. And indeed, we understand that human disaster is getting more and more serious. And actually, in terms of life losses and also property losses, human disasters is equally devastating than other natural disasters. And all we collect this data from only official statistic books published by the government. So all the data are official data. Now, for the 9 areas, we identify at least three major indicators within the same area to measure the seriousness or severity of that disaster in different provinces. So we select, actually not select, we cover all 31 provinces because it is available in the yearbook. And of course, certain major cities like Shanghai, Beijing is comparable and also included in the 31 provinces. And the data we use at least cover 5 to 20 years. It's depending on the availability of those data. And finally, we try to identify mitigation strategies for the most serious provinces in each area of the disaster. So it is what we are trying to do in this study. And eventually, we created a website called socialojo.org. And you are welcome to visit this website. And it is actually major information is in English. It's not in Chinese. So Ojo, as I learned a little bit of, I learned this word from my brother-in-law, and then it is Spanish. It means eyes. It means eyes. So we hope that this website can also open our eyes. All right. So we go to certain information. So first of all, by compiling GIS data, so for example, in typhoon, we can identify the most affected areas is Guangdong, Fujian, and Zhejiang. So it is here in the southeastern area provinces. I live in Guangdong, yeah, and then I teach in Zhuhai, so it's in Guangdong. Hong Kong and Macau is also in Guangdong. And then the next is Fujian, and then the next one is Zhejiang. Of course, the typhoon comes from the Pacific, so it explains why we have so many typhoons, and it was hardest hit. And then another map is about the snow disaster. The northern area, this trip is in the Mongolia. Interestingly, in the Mongolia, although it's north of the Hebei, but actually Hebei has a more serious snow disaster. Probably it is because of the geography. Of course, we have hills on this area, so probably the snow will become heavier on the northern side of the hills. And then Hunan, which is in the central China, is also one of the area with heavy snow. So it is quite interesting. And then, of course, a lot of geographers will be able to explain this. Okay, but at least it can help the layman to understand. We do not just think that the northern part will be more serious. Now we come to drought. The drought now in the Mongolia become one area with very heavy drought. That means sort of rainfall. And then also Liaoning and Jilin. So it's in the northeastern provinces. Because it is so dry, we can see that in the Mongolia also have a loss of forest fire. So the forest fire is very serious in this area. But interestingly, Sichuan, which is on the western province, it is in the middle. It's not in the northern part. It's in the western part, but it also have a lot of fire. And Guangxi, this province next to Guangdong, also have very serious fire. So after we find out this interesting phenomena, we have to find out why we create a lot of questions, raise a lot of questions to us. Well, after the natural disasters, we then turn to some human disaster. The first one is work-related injuries. You can see the work injuries, the highest provinces are those, the most serious provinces is on the actually eastern coast of China. So this is Zhejiang, and then we have Zhejiang, Shandong, this is Shandong, and then Hebei, and then also in Liaoning. And interestingly, Sichuan is also one of those places with high work-related injuries. Now, we understand that actually Zhejiang, Fujian, and also Guangdong are the first countries of first provinces that developed in industrialization, that go through industrialization. So normally we think that these three provinces will have higher levels of work injuries, but in fact they didn't show very high levels of work injuries. Of course, then we can think about perhaps it is because they do better preventions. So of course we have to confirm whether that is true. If they are more developed, they have more industries, but if they do a better job in prevention, then the work injuries may go down. So, so we have to go to certain trends, going back to certain histories to see whether this is the case, whether they have successfully bring down which were originally rather high figures. And we do not know Sichuan is also very high. So you remember probably that Sichuan also have a lot of fires, and then Sichuan is also affected by work injuries. So something has happened, so we need to study. And then another thing very interesting is about traffic accidents. We all understand that traffic accidents has become one of the major causes of death all over the world. It's one of the top 5 causes of death. And then we can see Guangdong this time has a lot of traffic accidents. And other provinces are Zhejiang, Jiangsu, Henan, and then also Shandong, and also Sichuan. Now, then I think it already ring a bell. Certain provinces are ranked the highest in several kind of disasters. Okay, so that is the geography of China, and probably geographical and human factors come into play. So we need more explanations. But can the GIS help us? Yes, actually, the GIS with a simple apps, they can also calculate certain data if we have the data. For example, we can compare trends with multiple indicators. To give you an example, this is traffic accidents. And then we have the several indicators, number of incidents, number of dead persons, number of injured persons, and then property loss. So we have at least 4 indicators for traffic accidents. And we can see that actually for most provinces, the trend is going down. Okay, everything is going down. It's okay. But on the other hand, we found that Shanghai has done a very good job, but we found in Hubei, when everyone is going down, it's going up. So perhaps we have to study why Hubei did a good job in preventing traffic accidents. And then traffic accident deaths is actually preventable. We have a lot of means to make traffic accidents preventable, and then allow the drivers and make sure that the drivers follow regulations and rules. And also we have a lot of measures about road design so we can minimize traffic accidents. So what kind of activities that we should do is a kind of questions that we can raise, and then we find out certain provinces need special assistance. Well, the GIS also allow us to add those indicators into a compound index. For example, if one disaster, we have 4 indicators or 5 indicators or 3 indicators, then we try to formulate an index. Of course, it takes a lot of statistical analysis. I just give one example. For example, work injuries. We can divide the work injuries and identify the key indicators. For example, the number 1 is injuries. How many injuries happened? And then occupational disease is different from injuries. It's also counted as one work disaster. And then traffic accidents during work is another occurrences. And violence at workplace is also accounted, record. And then death by the above reason. If there's a serious death, then we may consider that is another weighting. So we can add all these figures into one compound, combined kind of index. Now, so we can see Shandong is one of those provinces has very high work injuries. You can see that level 7 to level 10 means the highest, the most serious kind of handicap. And then we can see that it is growing up until 2018, but gradually coming down a little bit. And in 2021, it hasn't fallen back to 2014 level, but at least a certain prevention has been done to bring the curve down. Now, Sichuan is different. It's just the opposite. It has been successful in 2018 and 2019 to bring the curve down, but it bounced back in 2020 and then 2021. So it's not satisfactory. And then we can look at the figures of Jiangsu. Now it's coming down, but suddenly also bounced back since 2019. Of course, it hasn't bounced back to the highest point, but we have to think about strategies to further bring it back down again. Okay. Now, so this is the kind of information that we can develop from a GIS very simple apps. If we have that data, and then it can have all these kind of trends, and then maps, and then flow charts can be contained. Actually, they are all contained in the geographic map of China. Now, we can also formulate certain what we call temporal spatial data. That means we indicate places and also time together. Now, this is one example. We are talking about the cold. Actually, it's a low temperature. So we can have Shanxi, Inner Mongolia, Zhejiang, Fujian, Hunan, and Gansu. They all suffer from cold. And then we can see different provinces along the different years. So they have different performances. And of course, this one is the green line is Gansu. It seems that Gansu shoot up to 2013. Unfortunately, we only have figures until 2014. If we continue to bring in more data, then we can see whether Gansu continue to be the very cold area, and then how people are affected. I think this is just an example to show you that we can have temporal data and spatial data. And this is also another way of formulating a data that we rank the 3 most important, most serious provinces, and then we can calculate and rank all the provinces by a ransom ratio kind of statistics, and then we can know which countries, which provinces is the worst. And more important, we need to find the explanations. For example, like we use forest fire, then we see in the Mongolia, they do not have a lot of casualties, and the economic loss is not the highest, but it burned out a lot of lands. So actually, it's a lot of forest, and then it has a lot of negative impact on global warming and then carbon emission. But Sichuan they have a lot of casualties, these fires, and then they have lost a lot of money because it's in the urban areas. And in terms of affected area, it's not so high. So we can think about different strategy. For example, in Mongolia, we need remote sensors and then firefighting. So we need to control and provide early warnings. And then Sichuan, we have high life laws. So we have to do education, telling the people how to save their own lives when there is a fire. And then perhaps in Guangxi, we need to install fire barriers. So there are certain differentiation of mitigation strategy. Well, our time is running fast. So I would just skip this and then skip another analysis of mitigation of work-related injuries. I would just skip this. And then I would come to a certain conclusion. First of all, GIS data analysis contribute to EDRM, actually by helping us to first to understand, it enhance our understanding. Second, it allow us to design mitigation strategy with database, with evidence base, and then it also help us to do evaluation. Because after the mitigation implementation, then we have to see whether the figures really improved. So we have some limitations, and then hopefully we also have some implications. So to help other experts in China to understand. And lastly, I would like to also make some acknowledgement to my students and also to my institution. And I would like to share two pieces of news. First of all, our university has already started a bachelor program on digital social science, and digital disaster or digital emergency management is one course that I will teach. And also, we have formed EMCI, Emergency Management and Crisis Intervention.
Okay, well, we're waiting for Johnston's signals to come back.
So Johnston informed me that his presentation is basically finished, so we can move on.
Okay, we're going to take a short break here to reconfigure our schedule for this afternoon, since some of the planned speakers have had difficulty joining us. So please stand by, and we will be back shortly. Thank you.
Hello, everybody. Let's take now 15 minutes with an announcement to all of you. We told about Snezhana Knežis, and TIEMS has decided to honor her by presenting an award in her name. And I turn over first to Vinod and then to Roman to tell about this award. You are on, Vinod.
Thank you. Thank you, Harold. Actually, I think it's an honor and a privilege to be part of this announcement of the Snezhana Knežis award, the Memorial Award for the best student paper in the TIEMS annual conferences. We are actually starting this from this year. The TIEMS International, the International Emergency Management Society will be announcing this from the annual conference 2022, which is being hosted by the TIEMS US chapter. And I would actually just share the screen for a presentation. This is the Professor Snezhana Knežis Memorial Award for the best student paper in the TIEMS annual conference 2022. And Professor Snezhana was the TIEMS acting vice president and director of research and technical development, RTD activity. She did her undergraduate studies at the Faculty of Civil Engineering in the University of Split, Croatia in 1982 to 1987, and then her postgraduate studies, Master of Philosophy in the Faculty of Organization and Informatics, the University of Zagreb, 1988 to 1993, and she did a PhD thesis in the Faculty of Civil Engineering, University of Split, Croatia in 1998. She was a full-time professor of the Faculty of Civil Engineering and Architecture in the University of Split, and her research interests were in the application of system sciences and information technology, especially on decision support systems and GIS in emergency disaster management and other engineering fields. And she has published peer-reviewed papers on emergency management and disaster management. She was a member of ASCE, American Society of Civil Engineers, Croatian Society of Civil Engineers, GIS Forum Croatia, and the Croatian Mathematical Society. She was living in Split, Croatia with her family, and Professor Snezhana passed away on 4th September this year, just a few weeks ago. We felt that actually, we should we should use this opportunity to honor the memory of Professor Snezhana, who was very active in TIEMS, and it would be very useful if we can actually take a moment to appreciate her contributions and use this as a memorial award for the best student paper, not only for this year, but also in the subsequent annual chapters, annual conferences, which are happening next year in South Africa and the year after that in Croatia, in India. and in 2025 in Costa Rica and so on. So we feel that this will be a very appropriate way in which her memory will be honored and in all the subsequent annual conferences. This award will be presented to the best student paper in the TIEMS Annual Conference 2022 to honor the memory of Professor Snezana. And in the subsequent years, the Professor Snezana Memorial Award will be presented to the best student paper in the TIEMS annual conferences. And the best student paper will be selected by an awards committee consisting of board members nominated by the TIEMS president, and also will have the president of the TIEMS chapter hosting the annual conferences or his or her nominee. The awards committee can decide on the criteria for the selection of the best student paper. And, so we feel that this will be initiated from this year onwards. And now I would like to pass it on to Harold and Dr. Roman.
Yeah, Roman, please, can you add to this and present those who are under consideration to get the award this year?
So the committee and the board have had a discussion about this. We have come to the following conclusions: that the awards criteria will be presented in terms of what will be evaluated during the evaluation process and in the selection of the papers that will win the awards. And then we also drafted some criteria about who will be eligible. Now, from what we saw so far in the conference and what we will still see by the end of this week, there will be two broad categories that will be under consideration. These are people that are, or presenters who are currently registered for a postgraduate degree, either honors, master's, or PhD at a tertiary or higher education institution, and who are presenting papers in a given TIEMS annual conference. Or we will also consider students who have recently graduated or who have presented parts of their work that has resulted in a postgraduate degree, like the categories that I've mentioned, so honors and up. At the moment, what we have discussed is that the committee that will judge the candidates that I will introduce shortly, there will be 5 criteria that will be considered: quality of slides, presentation skills, methodology and the scientific or academic rigor, then results and discussions in the presentation and how well these were covered to see the completeness and understanding of the topic by the applicant, the ability to link their theoretical and methodological background to the data that they have collected, and then finally, to judge the candidate's ability to draw conclusions from their data and their research and propose significant interventions or draft descriptions of how they see the application of their results in the practice of emergency and disaster risk management in the future. So without further ado, these are the candidates that are chosen for 2022. Come on. Yeah. So we have chosen 2 presenters who have, I believe, recently or in the last 12 months or so completed their postgraduate degrees. These are Marilyn Tamayo and Grace and Dina, or they are currently finishing their degrees. And then we've got South African candidates, who was Robin Bain, who is currently studying. The first 2 candidates, I believe, were master's graduates or candidates. The third one is a candidate for honors degree who is currently completing her research in South Africa. We will have these 3 candidates have already completed their presentations. And then we've got Kelly Maguire, who will also present her master's research tomorrow. And then there are 3 recorded presentations which were submitted to the committee, and they will either be evaluated or they will be evaluated in the course of this week. And with the summary, I would like to just mention that I believe, have agreed on 3 awards. The first award, first place, will be awarded a prize money of $150 plus a year-long membership. Maybe I will pass it on to the TIEMS president to talk about the details. Thank you very much for your attention.
Thank you, Vinod and Roman, for working so fast on this. And yes, we have decided the following. $150 to the candidate, plus a diploma and 1 year free membership in TIEMS. For the second prize, we will give $100 diploma and also 1 year membership. The third one, $50, 1 year membership and a diploma. And they will also be presented on TIEMS website, and I will announce it worldwide. When this is said, we will not announce the winners this year before the end of the conference, so we don't discourage anyone who is presenting on Friday. So that will be announced at the end of the conference. I also like to say we will make up a financial fund where we will ask donations for future awards to students. So you're all welcome to contribute to Snezhana's student award fund. That's what I had to say now. We wanted to break in when there was some technical problems. So I'm turning over to you again, Tom.
All right. Thanks very much, Harold, Roman, and Vinod, for announcing this new award, Student Paper Award. We're returning now to our program on Chinese perspectives on emergency management, and I'm very pleased to welcome Dr. Gosheng Qiu, who's with the National Earthquake Response Support Center and has been a very long member of TIEMS, acting for many years as vice president and a friend we're glad to see here. So Gosheng, welcome. You will be talking on emergency broadcast systems based on disaster monitoring and early warning for end users, planning and application. The floor is yours, Gosheng.
Okay. Good morning, everybody. Now is the early morning in China. So I'm also very glad to be here to present my topic. So before my talk, I just say some words for the memory of Professor Shizana. And she is a very active person in the last 10 years of TIEMS. So my topic is the emergency broadcast system based on disaster monitoring and early warning in users, planning and application. So it's a topic of the techniques. And so here I showed about how to prevent the major natural disasters. For example, typhoon, storm surge, flooding, earthquake, tsunami, and geological disaster, and forests, and grassland fires, marine disasters, accidents, and also some urban comprehensive disaster. It is extremely important to timely monitor and warn personnel in various environment scenarios to effectively avoid disaster and also shelters before disaster and disaster come, and to establish a town to village emergency broadcasting system with monitoring and early warning function, so as to achieve the purpose of effective disaster reduction. So here we know China is a natural disaster impacted area. So here's the National Disaster Division map of China, and we can divide into 6 regions: Northern China and Northwest China, and also Central District, and also Eastern region, Southwest District, and Southeast District. So here we see the different colors show the different disaster area. And in the different area, the types and the degrees of the disaster is different. So in the northwest area, it's the mainly as earthquake, landslide, mudslides, and flash floods, and snowstorm, forest fire, and also sandstorm. But when we focus on the southwest area, as Tibet, and also Sichuan province, there are many earthquake, landslide, and also some floods. If we focus on the south east area as a typhoon, and also flood, and earthquake, and geological. So as different types, and also different risk. So based on the natural disaster division of Northeast China, Northern China and Central China, and in the different area, we are propose to build a demonstration of the monitoring and early warning, early emergency broadcasting and release system, integrating space, sky, land, and sea area in various disaster environments, such as land, sea, rivers, and lake, and urban area. And also the system is built by the 4-level monitoring and also early warning sites covering the city. So, and here, the construction of the monitoring and the early warning emergency broadcast system, the construction of the disaster early warning and the information release network, and then the overall layout of the urban monitoring and early warning emergency broadcast system from the site, surface, and networks, the city, district, street, community, and also all round coverage of urban jurisdiction area. So we establish 4 or more level monitoring and early warning emergency broadcasting system in the pilot area. So, and for example, we hope to give a pilot project in the Sichuan province, and in this area, we just planning for level 4-level monitoring. So, and first level site is fixed. So, and we commissioning monitoring equipment, spatial monitoring equipment. So we are we can for the disaster preparedness. So we have the ability to resist destruction, high precision, and high sensitivity, can track the evolution of disaster chain information. So it means maybe after the earthquake, we have a lot of landslide, and also because the big storm, so there's some mud flow and also flooding. So that's a big disaster chain. So, and every year there are many disaster and disaster chain cause the life losses. So, and we fix some high level or first level monitoring to whole round time and also whole conditions to monitor and warning, so we can prevent the people lost life. And also we can put this kinds of the monitoring in the car or in the UAV, and also in some removable transportation equipment, so we can high level monitoring, and also we can focus on this area to very quickly to move the secondary side to the disaster area. And then we have a 3 level, and also the level 3 and also level 4. So, and focus on the high density people's area. So, and we can just planning for these kinds of ground-based monitoring equipment. So we have a space and the sky and the ground, and also in the sea area. So, and here is for the major disaster events, maybe a rapid early warning and hierarchical control can be realized, and per disaster early warning and real-time emergency monitoring and early warning during disaster and post-disaster common message transmission can be quickly issued to the message through the side broadcast terminal in different scenarios, levels, regions, and time period. So, and we can focus on the early warning and also the broadcast for several kinds of disasters. For example, the construction and the capacity improvement of China's special disaster rescue system. We can find the following major disaster. For example, typhoon, flood, water, and disaster chain, and the rescue of building collapse, and also the forest and grassland fire, and earthquake, and this secondary disaster chain, and also earthquake, tsunami. For example, and all of these disaster, we can focus on our early warning and the broadcasting system. So the disaster, if disaster occur, the disaster early warning information is transmitted back to the relevant departments as soon as possible. So we divided the multi-level monitoring and early warning. So the satellite observation, UAV, helicopter, and ground, and the fixed, mobile, and emergency broadcasting system, and also the comprehensive reporting system. So if we have these kinds of monitoring and early warning system in the city or region, I think it will be a very useful to transmit back to the relevant department as soon as possible for the disaster information, and effectively improving the urban risk monitoring ability, and also the ability to prevent major and exceptionally large disaster. The ability to issue disaster early warning, and the ability to respond to the public, the ability to deal with disaster with precision, and the ability to prevent and control comprehensive disaster. So, now in China, we are just planning in some area. I think we combine the natural disaster monitoring, and also we are use the 4-level monitoring, and also 4-level broadcast in the users, so we can very efficiently to make a prevention of disasters, and also save lives. So that's my talk. And here Tom, I think maybe some connection programs for Chinese experts to give the presentation. So you can, if you put in contact with them and ask them to make a presentation. So you can find in the Zoom and tell me, and I can contact with Professor Li Xuefeng. Okay, that's my talk. Thanks a lot.
Thank you very much, Guo Sheng. Appreciate your jumping in. We have reached out to a couple of the other speakers and haven't heard back from them. So I think that what we'll do now is continue into the next section of the afternoon. We have two papers dealing with disaster and emergency management considerations in the Ukrainian war. The first paper will be given by Dr. Thomas Robertson. That's me. And as I introduced myself earlier, I'm TIEMS Regional Director for North America. I'm also the principal of a consultancy called Thinking TIEMS, which works with applications of artificial intelligence to harmonize human and machine intelligence. So I'm going to be speaking about restoration of communications in Ukraine using the Starlink satellite network. So I will start sharing my screen. Today I'm going to be talking about an incident in the current war in Ukraine that was a fortunate intersection between technology and government and commercial organizations. After Ukrainian communication infrastructure was destroyed during the Russian invasion, some of those communications were rapidly reestablished using ground stations and communication satellites in low Earth orbit. The way that this all unfolded, the way that this happened is thoroughly modern, featuring not just advanced technology, but also tweets and a billionaire entrepreneur. In my talk, I'm going to start with a description of the sequence of events that led to the loss and restoral of the communication, and talk about the impacts this had. Then I'll talk about the technology that made all of this possible. The problem. During the Russian invasion, tons of artillery shells have fallen, causing devastating death and destruction, including damage to cell towers and other ground-based infrastructure. And this is a problem, of course, because communications is critical during any emergency, particularly wartime. There are, of course, communications that are critical for coordinating emergency response activities, for coordinating military activities, and even communications between family members who are separated and need to find out about their well-being. And this ability to communicate throughout the population is really essential for the well-being of the entire community. During the event, the destruction of infrastructure rapidly led to a diminishment of, network traffic, both cell phone and internet, as shown here. A request was made on February 26th. Mikhailo Fedorov, who's the Ukrainian Vice Prime Minister and Minister of Digital Transformation, sent a tweet directed to Elon Musk, the colorful billionaire leader of a number of enterprises, including Tesla Motors, SpaceX, and Starlink, Starlink being a satellite-based internet service. The tweet from Fedorov referenced Musk's long-term goal to send people to Mars and SpaceX's successful reusable rockets. Fedorov and Ukraine had been very aware of Starlink. They had been in discussion with Musk's company for some months talking about the deployment of Starlink in Ukraine. And Musk and company were waiting to formalize the deal and get the official go-ahead. But in this case, Fedorov's tweet gave Musk the official okay, and he began to deploy his systems. And clearly, Musk found the opportunities to support Ukraine in this way very appealing. Note the time on this tweet. It's 4:06 a.m., February 26th, 2022. So that was the request. The response was pretty rapid. This is Elon Musk's response, saying the Starlink service is now active in Ukraine, more terminals en route. And notice the time, it's only about 12 hours later, 5:33 p.m. on February 26th. What this meant was that the Starlink satellite constellation, which I'll talk about in more detail later, was able to be modified through uplinks to be able to incorporate the area of Ukraine in its field of coverage. And with transportation help from USAID, 5,000 Starlink terminals were operational on the ground by the end of April. And continuing in subsequent months, continued support from Musk company as well as other European donors has resulted in more than 10,000 operational Starlink terminals on the ground by now. So a result of this, here's one example. This involves the city of Ypres, northwest of Kiev, as reported by Wired magazine. This city was devastatingly attacked by Russian forces, and on March 29th, the Ukrainian forces were able to recapture the city. They found the city littered with blackened wreckage and dead bodies. The destruction was awful, and it had knocked out all 24 of the city's cell towers. This prevented the traumatized survivors from even letting friends and relatives know they were safe. Only 2 days later, European was reconnected after engineers from Ukrainian Vodafone company mounted a Starlink terminal. You can see it, the round dish on top, to a generator-powered mobile base station on the edge of the city, restoring communications that had been severed by the destruction of the fiber optic communication networks, as well as power stations powering them. So within hours, the city was back online, and so were its remaining residents, who were then able to call relatives and let them know that they were safe. The speed at which Irpin was brought back online shows the ingenuity of the engineers involved and the nimbleness with which Ukraine's government has used these Starlink terminals. As I mentioned, by this time, the country has received more than 10,000 of these terminals since Russia invaded, in part thanks to funding and other help from the U.S. government. The terminals, as a result of this had an impact. Here's a follow-on tweet from Fedorov on May 6th, showing a makeshift application of Starlink. You can see on the photo on the left side there, a small, in this case, it's a rectangular Starlink terminal being mounted. And on the right side, there's a desk that is being used by the humanitarian organization Gostomel, enabling them to continue operations while the cable traffic that would normally carry their internet and calls was being repaired. So this was quite a coup for technology that's come along and become economically fairly recently. So let me talk about what's involved, what's behind this ability to use satellite networks and deploy them so quickly. Satellite communications has been around for quite a while. It's been around since early satellites such as Telstar began being used to relay communications from one part of the Earth to the other. The basic idea of satellite communications is to use them as relays. One point on Earth originates a signal, sends it to a satellite, which is then able to transmit it in a way that another point on the Earth is able to pick it up. In this simple diagram, the dotted lines encloses what's called the space segment of the satellite, which is consists of the satellite or satellites themselves, as well as a ground station that is used to control the satellite's activities. The Earth segment of the portion of the satellite communications network is shown outside the dotted lines, and this can include communications to and from the satellite with larger terminals that may be the entryway of regional networks. So, for example, in early days, satellites were often used to transmit television signals from central locations to television station affiliates throughout the country in the U.S. Another part of the Earth segment are smaller terminals that can be mounted on, for example, a roof of a house for customer premises. This is, for example, similar to the Dish Network and other providers of cable television through satellites instead of cables. And this is the sort of terminal that Starlink was deploying. As I mentioned, there are about 10,000 of these. And these are the smaller type terminals that are being deployed throughout Ukraine. So this is satellite communications in general. Let's talk about the particular flavor of satellite communications that Starlink represents. Satellite communication systems generally can operate at various orbital altitudes, and traditionally these altitudes have been classified into three basic ranges. The farthest away from Earth are the geosynchronous orbit satellites, GEO. They orbit the Earth around 23,000 miles away, and this orbit allows the satellite to, in effect, be synchronized with the Earth's rotation so that it remains over a particular portion of the Earth. And because the satellite is so far away, it can cover about 42%, a single satellite, about 42% of the Earth's surface. However, there's some drawbacks to being that far away. One is that signals take a relatively long time, 60 milliseconds, over 600 milliseconds, over a half a second to travel the distance between the Earth and the satellite. This is called latency. The other problem is that a consequence of such a high orbit is a high cost. It costs a lot, as much as $500 million to launch such a satellite, and the satellites themselves must be built to have sufficient power to transmit over such a long distance. And the launch vehicles, therefore, have to be expensive as well, having to carry a heavy payload to a very large distance from the Earth. The other extreme from geosynchronous satellites are low Earth orbit satellites. These orbit much closer to the Earth. For example, Starlink is about 340 miles from Earth compared to the 23,000 for geosynchronous orbit. And this greatly reduces the latency from 600 milliseconds to 50 milliseconds. And these satellites can be much cheaper to build and launch since they need lower power to transmit the relatively shorter distance, and their lower orbits require smaller launch rockets. However, each satellite being so close to Earth can only cover about 2.6% of the Earth's surface. And this means that if you want to cover a broad geographic area, you need multiple satellites. So the use of multiple satellites is not something new. It's been used in several applications. One of them is GPS, which we all use to navigate through our smartphones. GPS happens to be in medium Earth orbit, so it's between those very distant satellites, geosynchronous satellites, and the low Earth orbit satellites. GPS satellites orbit at about 12,000 miles. And in order to provide the coverage for GPS, because of the way it works, 4 satellites need to be visible to a point on the ground. Here, this is an animation from Wikipedia showing a constellation of 4 GPS satellites, and there's a single red point on the ground, and it shows as the Earth rotates and the satellites proceed along their orbits, that during various times, various satellites are within signal range of this particular point on the ground. So this is what happens when your app, such as Google Maps, locates you on the surface of the Earth. They're communicating to these satellites, and the constellation works because the orbits have been configured and the distances and the launch and control of these satellites such that the Earth, particular portions of Earth, will gain the coverage. The Starlink constellation is much closer than GPS. GPS being 12,000 miles, Starlink, remember, is about 340 miles. So this requires a lot more satellites. So right now there's around 3,000 Starlink satellites in orbit, and they've sought approval for up to 42,000 satellites. As you might imagine, this looks pretty crowded, and there is concern about the possibility of collisions in orbit because of so much orbital stuff. Already there are spent rockets and portions of destroyed satellites that are orbiting, and some projections are that within a decade or so, there could be as many as 80,000 satellites in low orbit. I think right about this time, there was around 11,000 satellites, starting with Sputnik 1 in 1957, which is a low Earth orbit satellite. So there are concerns there, but one thing to consider is that, for example, there's a lot of space in space. It doesn't quite look like it in a diagram like this, but even though Starlink satellites are in low Earth orbit, and so is the International Space Station in low Earth orbit, their orbits differ from 100 by 100 miles. So that's a pretty good margin of error. However, there have been concerns. I think there was an instance where Chinese space station actually had to take evasive action to avoid a communication satellite. And what's really needed is a space-based version of air traffic control, because with sufficient warning, the danger isn't so dense that you couldn't arrange your orbits and potential evasive maneuvers to stay safe. But there are going to be increasing numbers of satellites in orbit. So finally, I want to talk about, SpaceX innovations. What are the innovations that make these low Earth orbit satellite constellations possible? In the case of SpaceX, they created first a set of low-cost satellites that are very carefully designed. This satellite, as you can see in the picture, it's about the size of a coffee table that you might have in your living room. and it contains the means to receive and transmit signals from the Earth, and also a means to communicate with other Starlink satellites via laser. It also includes, it's a little hard to see in this picture, but there's an unfolded black solar panel that juts out perpendicular to the main plane of the satellite and provides power. Another innovation was mass producing Earth terminals at a low cost. So these are the terminals that have been sent to Ukraine and find themselves on roofs on top of mobile communication stations. And here you can see you can even mount it on a sort of a stand. And where SpaceX actually started was competing through government contracts for low-cost launch platforms, which are achieved by reusability. And these rockets are reused, as you may know. SpaceX rockets, once being launched into space, can come back down to Earth and land and be reused. In addition to that, paired with the design of these satellites, the satellites are designed to tuck into the SpaceX Falcon 9 missile. And as you can see here, it's a little hard to see, but these missiles can launch 60 of these satellites. That's 60 of these satellites at one time. So that immensely reduces the cost of launch, which had always been a barrier to any kind of communication satellite constellation that required launching many satellites. Obviously, if you're spending a lot of money per launch, it becomes very difficult to do. But SpaceX has addressed that problem by launch vehicles that are much lower cost than previous ones because of their reusability, and also by being able to launch 60 satellites at one time. So in conclusion, it's clear, obviously, communication are essential for emergency management. And we increasingly rely on the benefits of internet and cell phone communications. And these are enabled typically by ground-based infrastructure that is vulnerable to disruption by war or natural disaster. And what we're seeing is that the emerging capabilities of these satellite-based internet is less vulnerable and is a great solution to be able to bridge the gap when ground-based infrastructure is destroyed or in danger through emergencies, particularly the kind of destruction that has been occurring through the Ukrainian war. All right, thank you. That is the end of my presentation. Okay, I see that we have another one of our Chinese colleagues online, and this is Zufeng Li, who is a member of the China National Academy of Governance, and he will be talking about China's emergency management modernization at the 14th five-year plan period. I welcome Dr. Li, and hope you will be able to present for us.
Hello. Hi, let me share my PPT. Good afternoon, everybody. In fact, here I'm in China, and it's morning, in the morning, 3 o'clock. It's my pleasure to give my presentation about the China's emergency management modernization at the 14th five-year plan period. The 14th five-year plan begins from the 2020 to 2021 to 2025. In this 5 year, the 5-year plan was published in every area, including the emergency management area. And the 5-year plan in this round is basically to plan the next 5 years till to 2025 and to a longer term vision toward 2035. So it is both a 5-year plan and in fact 15 years plans. So here I would like to share certain basic ideas in the 5-year plan, include the following issues. First, about the challenges. Second, the principles of emergency management in China. And the third, new aims in the 5-year plan, especially the 4 points here: the rule of law response, scientifically smart response, and joint governance. Maybe I will not just read the PPT. I will express my opinion and the situation just orally. So here about the challenges, China now we feel certain situations is getting better. For example, in China we defined the particularly serious public safety accidents as when the incidents or accidents caused more than 30 people lost their lives. In recent years, we have very few such serious incidents. It's good news, but there are many bad news. For example, in the first half of this year, we have one building collapsed, cost more than 50 people lost their lives, and one airplane just crashed. Yeah, hundreds people lost their lives. In other areas, natural disasters, as the global warning, this year more droughts, here. And last year in a central city called Zhengzhou in Henan province, a heavy rain caused 380 lives. So emergency management now in China is really a great challenge, let alone to say the COVID-19 here. Everybody knows that China is now still undertaking a policy called dynamic zero policy. So people may say, okay, why you are so strict? I think it's a dilemma for the Chinese government. We want to be loose, and a better, so-called a better economical environment, a freedom life. It seems good. But to the Chinese, to the central government, if we lose a little and then COVID-19 everywhere, it means that China, only in this year, we may lost 1 million more lives. Yeah, we're modeling that. So it's a serious civil issue, both and a political issue. So it's not easy for us. And let alone to say that the whole emergency management system is not so mature. This is why we always say that we need to catch up with the advanced country. We need to modernize our system. So this is our background. On the one hand, disasters, risks, they are there. On the other hand, on the other side, our capability is still low. It's not so strong. So how should we build up our system? In our 5-year plan of national emergency management, the central government listed all these 6 principles that we need to insist. The first is adhering to the leadership of the Communist Party of China. So it's somewhat different from many other countries. Every country have your own political parties. But in China, historically, at least in the last 70 years, the governing party is the CPC. And the CPC, we have more than 90 million members. In each community, the core volunteers are formed by the CPC members. And of course, at each layer of the government, it's the CPC committee exert like a decision-making group. So, for example, for the COVID-19, it's a difficult challenge to deal with. It's millions of the Communist Party branch that support a community in a order. So this political principle should be insisted. And others, including putting people first. So why we insist dynamic zero policy? We take people's life first. We could not tolerate that 1 million or more people lost their lives. And the third principle is to put prevention first. It seems quite naturally, but in many areas in China, maybe local officials, they fear that when any disaster occurred, people lost their lives, and then they lost their position. So it seems putting prevention first reasonable, but in fact, they do not insist or they do not keep working hard on preparation, on prevention. So we need to emphasize that. Others, including adhering to governance according to law, adhering to a smart governance, and adhering to social co-governance. So these are the basic principles. So under the principle, the 5-year plan set up new aims for the 2050, 25, and 2035. So the core ideas for both the aims are just to try to step by step to lead our emergency management system to a advanced or a better level. To explain this, next I will emphasize the 4 points. First, the rule of law. So what's the real situation in China now? I think we have 2 shortcomings, or 3 shortcomings, basically. The first, we haven't have enough laws, regulations, standards, or efficient plans, emergency operation plans. For example, in the United States, when I visited FEMA, officials there tell me that they have at least 3,000 documents legal documents only in this one department. But in China, we have newly set up the Ministry of Emergency Management. I think we have hundreds of such legal documents. So we need to catch up. The second aspect or the second shortcoming here in China is many officials, they are not quite automatically or maybe willingly to follow the rules. For example, I mentioned the example last year in Zhengzhou, a city with a municipal with 10,000 with 10 million people. The heavy rain cost nearly 400 people's lives. But when we investigate that, we could find that at least 30 organizations, including government departments and private organizations, they just do not follow a somewhat law or operational plan in 111 aspects. So to be briefly, 111 document points or document items was disobeyed by the organizations. So we need to follow the laws when the law was published. We need to follow the operational plans when the plan was published. So this is a serious issue. We need to train people to tell them how to follow the laws. And the third shortcoming now is that in the whole society, many ordinary people, the community, they do not have a strong awareness of the rules or the laws. So we need to educate the communities, to educate people in schools, in factories, in rural areas, everywhere. So the rule of law, the principle, it is also an aim. We have detailed aims. Yeah, it's quite fundamental, and it's a hard work to push the rule of law. Of course, we have confidence. We still have 5 years, 15 years to do this. This is the first point. The second part of the future aim for future, is to respond scientifically. I think this is a somewhat Chinese impression. So in China, to respond scientifically means lots of things. For example, we need to follow the law of nature. But here in the 5-year plan, we emphasize two items, two sort of important issues. The first is prevention first. To not only respond to incidents, respond to disasters, put more emphasis on prevention. In the 5-year plan, we have planned a series of projects to prevent major disasters. And the second aspect is accurate governance, which means when any disaster comes, we should react accurately. Yeah, accurately. Why we say this? Because nowadays, it is always or very frequently, people would like to recreate more than really demand. More volunteers arrived on site. In fact, we do not need so much people. Yeah, more materials. Yeah, more officials. So now we would like to push to achieve accurate early warning release, accurate rescue, accurate recovery, and so on. The third point is smart response. The smart response means that we need to apply more big data, mega data technology, more AI, yeah, more information system to work for us. So now smart cities, yeah, smart everything, yeah. So it's quite popular now, but in fact, it's not easy. As we all know, re-engineering a system, we need first to re-engineering the process, and then to make our technology to support that. But people here in many areas, they just love to have a quite advanced system, a big budget, but how to make the system to work well? Do you have AI? The answer mainly is no. We now have certain pioneer projects. They work very well. For example, for the Ministry of Emergency Management, we now can monitoring 3,000 mining companies in time, just in time. So in the future, I think following this 5-year plan, we will have more efficient, smart systems, yeah, or AI-aided emergency management systems. And the last point is the joint governance. So joint governance is getting a trend in modern society. And in China, we have our characteristics. We have mentioned that, for example, the Communist Party of China is everywhere. Yeah, the pioneers or the most proactive peoples are basically absorbed in the party. So we need to insist the leadership of the party. I should say that it does not mean a control to the community or what. The leadership means the party members, they need to work harder than ordinary people. They need to take more responsibility than ordinary people. And of course, they need to take the responsibility for difficult decisions in emergency management. Besides this, all these, the government officials or government sectors, government departments, they need to take up their responsibilities. And then the other side is the social co-governance. We need to activate, to mobilize more people in the societies. For example, we know in the United States, the community volunteer team members may arrive nearly 1 million, I think, at present. In China, every province is trying to push this. For example, in a community, will build up a voluntary team of about 10%, and this 10% need to take part in a training program of at least a week. And then whenever any disaster arrives, the 10 people, they can work as the core team in the community. But it's imbalance. In certain provinces, for example, in Guangxi, they have trained a dozens of thousands people that formed in the volunteer teams in most of the communities. But in many other areas, it's relatively weak. We need to push this ahead. So now, here is what I would like to share with you quite briefly about the Chinese 5-year plan system in emergency management, especially the national level 5-year plan of the emergency management. You may ask that, how could you implement the plan? In fact, this is the national level plan, and under this plan, each province we have 34 provincial level government, including Hong Kong, Macau, and Taiwan, but exclude the 3 areas. They are somewhat separate. The other 31 provincial level government, they all published their own 5-year plan for emergency management. And under the provincial level, we have municipal level governments, somewhat more than 600, and then more than 3,000 county level governments. All these thousands of different level of governments, they basically have published their and implementing their own 5-year plan for emergency management. So the implementation is a network. In China, it's basically not a problem. We can observe that basically every 5-year plan will be implemented. The main tasks will be realized in history. So we believe in that after the COVID-19, when you have a chance to visit China, you visit our emergency management ministry or certain emergency management bureau, they can show you some beautiful scenarios or a better situations than years before. So thank you very much. Thank you.
Thank you, Dr. Lee. Very interesting and clear description of the perspective in China, which is so important, really emphasizing the importance of local conditions, not only geological and atmospheric, but also political and organizational. And I think it's great to share this information, because as a world, we need to cooperate in emergency management, and we have a lot to learn from each other.